Today we'll start our next unit. The next unit is the unit 3, and unit 3 is the Fourier representation of aperiodic signal. Now, as we have already studied about the periodic signals in unit 2, unit 2 was the Fourier representation of periodic signal, and that was nothing but our Fourier series that we studied in unit 2. Now, in this unit we'll be studying about the Fourier representation of aperiodic signal. Now, since I've already explained this thing in previous classes, whenever we are working on a continuous time signal, the signal may be either periodic or aperiodic, that is non-periodic. Okay? So when we talk about periodic signal, the periodic signals are completely analyzed, and they are they are been analyzed by the Fourier series. Now, Fourier series has a limitation that it works only for the periodic signal. The periodic signal, but the signal has to be periodic in nature. Then only we can make use of Fourier series. Otherwise, the Fourier series doesn't work for aperiodic signal. That is the basic limitation of a Fourier series. Now, in nature, as we all know, all the signals they can never be periodic in nature, right? They may be periodic in nature, but always it is not possible that all the signals will be periodic in nature. So we come across with the number of signals in real time and in the day-to-day life that all the signals are usually non-periodic, right? They are usually non-periodic, and these non-periodic signals also needs to be analyzed and they need to be processed further. So for those signals which are aperiodic in nature, we have come up with the another method which is known as Fourier transform. Now, Fourier transform is the way of representing the aperiodic signal. Okay? That is, it's a way of representing the aperiodic signal. Now, when we talk about aperiodic signal, that is non-periodic signal, these signals, not only these signals, the Fourier transform can even represent all the signals, that is whether it is periodic in nature or non-periodic in nature. So we can make use of Fourier transform method for analyzing any kind of signal. What I'm saying is any kind of signal, any kind of signal, whether the signal is periodic in nature or whether it is non-periodic in nature. But when we studying about non-periodic signals right now, we will not focus on periodic because that we have already done in the previous unit. Clear? So the previous unit we have studied the Fourier representation of periodic signal. The third unit will be studying about the Fourier representation of aperiodic signal, and that will be done through Fourier transform. Fourier transform is mostly used, they are mostly used for aperiodic signal, but still we can even use it for periodic signal. Now, what are actually this Fourier transform? Fourier transform hota kya? It's a kind of transformation technique. It's a kind of transformation technique where we are converting the time domain signal into frequency domain. Now, what is the need of converting the time domain signal into frequency domain? Because that is making our processing system, that is analyzing system, more easier. Our frequency domain we have to easily we can find its magnitude, its phase, and all the stuff. Okay? So that is the only reason that we transform the signal from time domain to frequency domain. Clear? So that's a type of a transformation, and it is benefited, that is, it is mostly used over Fourier series because it can be used for aperiodic as well as periodic. So it is overcoming actually the drawback of the Fourier series. What is the drawback of Fourier series? That it is used only for periodic signal. The drawback of Fourier series is used only for periodic signals. But the Fourier transform will make use of Fourier transform and it is overcoming the drawback of the Fourier series. It is overcoming the drawback of the Fourier series. Now, it is nothing but a transformation technique, as I have already explained, which transforms the time domain signal to frequency domain signal. Now, if we write the Fourier transform of a periodic signal, let us say of a periodic signal, then we may write let x of t be any non-periodic signal. Fourier transform is given by capital X of omega. Fourier transform is given by capital X of omega, and this is equals to integration minus infinity to infinity x of t e to the power minus j omega t dt. Now this is actually the way that we convert the xt into x omega. We are given with xt is nothing but a signal in time domain. Okay? Xt is a signal in time domain. And what are we obtaining now? We are obtaining the x omega of it. X omega is the frequency domain transformation of xt. Okay? So x of omega is the Fourier transform. Basically, it's a Fourier transform of xt, and the formula for converting is integration minus infinity to infinity x of t into e to the power minus j omega t dt. Okay? Now here x omega represents, we need to know what actually an x omega is. It represents the frequency spectrum of xt, and is called as the spectral density function. Spectral density function. It is called as spectral density function. It is also known as Fourier transform. Of xt, or we can even call it as Fourier integral of xt. So these are the different names given to x of omega. We need to know what actually x omega is. It is the frequency spectrum of xt, and it is also called the spectral density function. Now we are even calling it as Fourier transform. Basically, we will call it as Fourier transform only. Okay? So the Fourier transform of xt, or the Fourier integral of xt. So this is how we are defining our x of omega. Okay? Now the next is, if we have to obtain xt. Now if we are given with x of omega and we have to obtain xt, we can even go in the inverse process. That is the reverse process, and xt can be obtained by 1 by 2 pi integration minus infinity to infinity x omega e to the power j omega t d omega. Now this is how we can obtain xt from x omega. If you are given with x omega, it will definitely be a function of frequency, the angular frequency. So it will be in d omega terms. Okay? So x omega, it will be j omega t d omega. And this is the time domain function. Xt is a time domain function. It will be in dt terms. Here it is a frequency domain function. It will be d omega. That is the only difference. It is 1 by 2 pi integration minus infinity to infinity x omega to the power j omega t d omega. Here it was xt into e to the power minus j omega t dt. That is the difference. Now xt is what? It is the inverse Fourier transform of x omega. Okay? It is the inverse Fourier transform of x omega. Now both the formulas, this one and this one, they are known as x omega and x of t are known as Fourier transform pair. Fourier transform pair. Definitely there will be a pair. xt से x omega मिल रहा है, x omega से xt मिल रहा है, and we are writing it as x of omega will have the Fourier transform done on xt. X omega is the Fourier transform on xt, and if we are writing x of t, it will be the inverse Fourier transform on x omega. Inverse Fourier transform done on x omega. ठीक है? So that is how we write. If we are writing xt Fourier transform x omega. This is how we'll write. That is, we'll have to write here Fourier transform because that is required. Because we need to know what is the thing that we are applying to x. xt we are applying Fourier transform. We are getting x of omega. ठीक है? So that was the basic about the Fourier transform. Now we'll study the magnitude and phase. Magnitude and phase representation. Now, magnitude and phase representation of Fourier transform. Now, we will be obtaining the magnitude and phase representation of Fourier transform. We are not working on we will be not working on xt because xt is a time domain function, and we cannot obtain the magnitude and phase in time domain because that is always in the frequency domain versus omega. It will always be versus omega. So that is required. So magnitude and phase representation of Fourier transform x omega. Now we know that x omega is a complex valued function of omega. It is a complex valued function of omega. So we can write our x omega as x r omega, that is the real part of x omega, plus k x I omega. Now x r omega is the real part of x omega, and x I omega will be the imaginary part of x omega. And if we have to find the magnitude, of x omega is given by mod x omega equals to root over xr omega square plus xi omega का square. Definitely it will be a square of this one plus square of this one का under root. ठीक है? So root over xr omega square plus xi omega square. That is the magnitude, and the phase of x omega will be given by tan inverse xi omega by xr omega. So this is how we obtain the phase, and this is how we obtain the magnitude of x omega. If we have the x omega, it will be in the complex form, that is x real omega plus d times xi omega. The magnitude is obtained by this one. The formula is root over xr omega square plus xi omega square. And if we have to find the phase, it will be tan inverse xi omega by xr omega. So that this is nothing but the amplitude plot, amplitude spectrum, and this is the phase spectrum. You already know this one is an amplitude spectrum and this one is a phase spectrum, and both combinedly they are called as frequency spectrum. Okay? So they are the amplitude and the phase, they combinedly called as frequency spectrum. Now coming to the existence of Fourier series. Again, existence of Fourier transform. As we have already studied in the Second unit, that existence is very important, and how do we find that whether the Fourier transform of a particular signal or a particular aperiodic signal exists or not. For that thing, certain conditions are there that needs to be satisfied, and then we declare that when these conditions are satisfied, definitely the Fourier transform will exist. Okay? So write down the existence of Fourier transform. Existence of Fourier transform. Now, when we say that existence of Fourier transform, it does not exist for all aperiodic signal, all aperiodic function. It does not exist for all aperiodic signal. Certain conditions of xt, the conditions that should be satisfying for xt are known as Dirichlet's conditions. They are known as Dirichlet's conditions. Same person, Dirichlet, he has come up with the Dirichlet condition in case of Fourier transform as well. That was the condition in case of Fourier series also. The same here, in the case of Fourier transform also, the conditions are known as Dirichlet conditions, and the conditions are, first one, the condition is xt is x of t is absolutely integrable. ठीक है, xt is absolutely integrable over interval minus infinity to infinity. That is integration minus infinity to infinity x of t dt should be less than infinity. So this is the first condition, that it is saying the xt has to be absolutely integrable over the interval minus infinity to infinity. That is integration of minus infinity to infinity mod of xt dt should be less than infinity. This is the first condition. Now coming to the second condition, it is saying that xt has a finite number of discontinuity. Xt has a finite number of discontinuities. In every finite time interval. In every finite time interval. मतलब if you are taking particular finite duration of time, for that particular finite duration of time, there must have the finite number of discontinuities. ठीक है? Third point, it is saying that xt has finite number of maximum and minimum in every finite time interval. So these are basically three conditions that needs to be satisfied to have for the existence of the Fourier transform. First, it is saying xt should be absolutely integrable over the interval minus infinity to infinity. And the second, it is saying that it should have finite number of discontinuities in every finite interval of time. Third, it is saying xt has finite number of maxima and minima in every finite time interval. ठीक है? तो हर finite time interval में it should have the finite number of maxima or finite number of minima. Now it is saying that the Dirichlet condition is a sufficient condition. These conditions conditions are sufficient conditions but not the necessary condition. मतलब necessary जरूरी नहीं है, sufficient है. These are sufficient condition but not necessary conditions. ठीक है? So we'll see now the Fourier transform of standard signals. Fourier transform of standard signals. ठीक है? First one, let's start with the impulse function. Let's start with impulse function. That is del t. Now we already know what is del t. Del t is 1 for t equals to 0 and it is 0 for t not equals to 0. This is our del t impulse function. It is 1 at t equals to 0 and it is 0 for t not equals to 0. Now we have to found the x omega of it, and what is the formula? It is minus infinity to infinity x of t to the power minus j omega t dt. Now here we have to put del t in the formula. This will be minus infinity to infinity del t e to the power minus j omega t dt. What would be the answer? इसका आंसर कितना आएगा? Fourier transform जल्दी से बताओ. What would be the answer of it? Just tell me fast. Del t integration minus infinity to infinity to the power minus j omega t dt. What is the answer of this particular integration? Give me the answer fast. Fourier transform of del t. Yes, reply fast, students. I am waiting. I want every one of you to be attentive in the class. This one is very simple. Just give me the answer. Del t exists only at t equals to 0 and the value is 1. So what is it? Yes, correct. It's 1. Definitely this will be the value e to the power minus j omega t. That is this one, because this has the value 1 only at t equals to 0. ठीक है? तो ये आपका t equals to 0 हो जाएगा. So the value will be 1. So x of omega is 1. That means the Fourier transform of del t is 1. So we need to remember this thing, that the Fourier transform of del t is always 1. ठीक है? So this is how we can even write this as del t as Fourier transform 1. ठीक है? So this is the first one. Now we'll go to the next one. If I write the Fourier transform of del of t minus t naught e to the power minus j omega t dt, कितना आएगा ये? Del of t minus t naught e to the power minus j omega t dt. What would be the answer of this one? इसका आंसर क्या होगा? This is integration. I am just replacing it. That is, I am shifting time t minus t naught. Then in that case, what would be the answer? Yes, it's not 1. Why it will be 1? Then t minus t naught. T naught will be t naught may be any value, right? It will be any value. That will be e to the power minus j omega t naught, right? It will be e to the power minus j omega t naught. ठीक है? So whatever is the value of t naught, for that particular value, the answer will be this one, e to the power minus j omega t naught. Minus भी रहेगा because it's already here. ठीक है? So the Fourier transform of del t minus t naught will be e to the power minus j omega t naught. That is a simple thing that we need to understand. Now the next is single sided real exponential function. Real exponential function. Now what do you mean by single sided? That is, in this case my xt will be e to the power minus 18 ut. Ut मतलब it is just a single sided function. ठीक है, so it will work only for t greater than 0. We may even take for t less than 0, that is u of minus t. But right now let us just take for a single sided function. ठीक है, so if xt is e to the power minus 80 ut, what would be its Fourier transform? निकालो जल्दी से फटाफट. Integration minus infinity to infinity. This is e to the power minus 80 into ut e to the power minus j omega t dt. कितना आएगा इसका आंसर? कितनी आंसर? This becomes 0 to infinity because it has ut attached to it, and this becomes e to the power minus a minus taken out a plus j omega t dt. A plus j omega t dt. Now what is the answer of this one? X of omega. This becomes e to the power minus a plus j omega minus a plus j omega is taken out 0 to infinity. Okay, this is the integration e to the power minus a plus j omega by minus a plus j omega, and the limits will be 0 to infinity. And what is it? Minus a plus j omega in the denominator will be taken as it is. This is e to the power minus infinity. ठीक है, e to the power minus infinity मतलब 1 by e to the power infinity minus e to the power 1 by e to the power minus 0. तो 1 by e to the power 0. तो कितना आएगा इसका आंसर? ये x ओमेगा will be what? Yes, x omega कितना आ रहा है यहाँ पर? If you solve it, 1 by e to the power infinity, this becomes 0, this becomes 1. ठीक है, this is 1 by a plus j omega. ठीक है, 1 by a plus j omega. Correct. So we can write that the Fourier transform of e to the power minus 80 into ut is 1 by a plus j omega. ठीक है, it is 1 by a plus j omega. A plus j omega है, 1 by a plus omega नहीं है मतलब it will be 1 by a plus j omega. ठीक है, now that is how we can obtain the Fourier transform for a single sided function. Now we can even find its magnitude phase plot for the same. हम इसका magnitude और phase plot भी कर सकते हैं. We can even plot the magnitude and phase for any type of signal. किसी भी function का हम लोग कर सकते हैं. x omega है तो अगर हम इसका a by mod of x omega निकालेंगे, that will be this one root over a square plus omega square. ठीक है, and if I take the face of this is minus tan inverse omega by a. ठीक है, that is minus tan inverse omega by a. So this we can easily plot. In fact, अगर हम इसको plot भी करते हैं, this will be like this is omega and this value will be 1 by a. So this is mod of x omega, and if I plot the phase, it will be like this. This is pi by 2 and this value will be minus pi by 2. ठीक है, so these are the amplitude and phase plot of this particular single sided function. ठीक है, now we can go for the double sided function. Third one is double sided real exponential function. Now double sided, if I am taking, in that case xt will be e to the power minus a mod of t. ठीक है, e to the power minus a mod of t, and this is nothing but e to the power at for t less than or equals to 0 and e to the power minus at for t greater than or equals to 0, because it will be t will be as it is for t greater than 0 and for t less than 0 this will be minus t. ठीक है, so it is already e to the power minus a into minus t will be e to the power at, and this is e to the power minus a into t for t greater than 0 will be e to the power minus at. This thing is clear, right? So that this is our function for double-sided real exponential function, and we can even write it as this one as e to the power at into u of minus t, that is this is for t less than 0 plus e to the power minus at into u of t for t greater than 0. So this is how we are representing our xt for double-sided real exponential function e to the power at u of minus t, e to the power minus at into u of t. Now this, after applying it in the formula of Fourier transform, it will be, find out the Fourier transform of the double-sided real exponential function. Fourier transform निकालो इसका, x of omega will be, it will be in two parts, minus infinity to 0 for this one, this is for minus infinity to 0, it will be e to the power at, ठीक है, and this is e to the power minus j omega t dt, plus the another part is 0 to infinity e to the power minus at e to the power minus j omega t dt. ठीक है, so this is the first part minus infinity to 0, this is the second part 0 to infinity. So I'm written it in two parts. Now after this becomes minus infinity to 0 e to the power a minus j omega t dt, ठीक है, plus 0 to infinity e to the power minus a plus j omega t dt. This part we have already done, we have already निकाल चुके हैं, right? This is the part that we did right now for the one-sided real exponential function. Now this is the added part in it, and find out x of omega. ये part का आएगा 1 by a minus j omega plus 1 by a plus j omega for second part. ठीक है, this is the integration of this will be 1 by a minus j omega, and the integration of this we have already obtained, that is 1 by a plus j omega, and it will be, if we take it in combined, it will be 2a by a square plus omega square, 2a by a square plus omega square. ठीक है, so that is how we can write both the functions 2a by a square plus omega square. Here now we can write it as Fourier transform of e to the power minus a mod t is 2a by a square plus omega square, and if I take the magnitude of it will remain same, 2a by a square plus omega square, because it doesn't has any imaginary part. यहाँ पर इसमें कुछ भी imaginary नहीं है, 2a by a square plus omega square for all omega. And what would be the phase of it? X of omega will be 0 because it doesn't has any imaginary part. ठीक है, imaginary part is 0, तो 0 है, तो it will be 0 for all zeros, for all omega. ठीक है, for all omega it will be 0 and this is the magnitude. Is this thing clear now? So that is how we have obtained for two-sided function. Now we will obtain for complex exponential function. Fourth one is a complex exponential function. A complex exponential function that is e to the power j omega naught t. Let us take it as e to the power j omega naught t. Now, since this is e to the power j omega naught t, a complex exponential function, if we try to obtain it in a proper way, that is by taking the Fourier transform of it, that will be a little difficult for us. Because it is e to the power j omega naught t and it will not be able to find the proper way. So because of that, let us find the inverse Fourier transform of, let us find the inverse Fourier transform of del omega minus omega naught. Then omega minus omega naught का हम इनवर्स फूरियर ट्रांसफॉर्म करके सॉल्व करने की कोशिश करेंगे. ठीक है, now let's see what is the inverse Fourier transform formula. X of omega निकालने का formula, x of omega given is del omega minus omega naught. Then with this we can find x of t as 1 by 2 pi integration minus infinity to infinity x of omega to the power j omega t t omega. This was the formula to obtain the x of t from x omega. So let us just put the value of x omega 1 by 2 pi minus infinity to infinity. X of omega is del omega minus omega naught to the power j omega t d omega. Now what is it? कितना आएगा? If we just write it in the formula, this one then omega minus omega naught and this will be इंटीग्रेशन का आंसर कितना आ रहा है जल्दी से बताओ. Here it is d omega. d omega के टर्म्स में है. So अगर हमारा ओमेगा शिफ्ट हो रहा है ओमेगा नॉट, तो what will be the answer of this Fourier transform? Inverse Fourier transform 1 by 2 pi integration minus infinity to infinity. This is then omega minus omega naught e to the power j omega t. T is not a variable here. What is the variable? Variable is the omega. ठीक है, तो what is it? कितना आ रहा है? This will be 1 by 2 pi e to the power j omega naught t e to the power j omega naught t. ठीक है. Now from here, since we have got the Fourier inverse of del omega minus omega naught is 1 by 2 pi e to the power j omega naught t. Then what would be the Fourier transform of e to the power j omega naught t? It will be 2 pi del omega minus omega naught. It is direct, very direct. ठीक है. So hence we can write that the Fourier inverse of 2 pi del omega minus omega naught is nothing but e to the power j omega naught t. Hence, the Fourier transform of e to the power j omega naught t is what? It will be 2 pi del omega minus omega naught. ठीक है? Now since we have done it in this way, हमने क्या किया था? We try to obtain the inverse Fourier transform of del omega minus omega naught. Now how did this came to our in mind? कि हमें इसका inverse Fourier transform निकालना है. Because here it is given what is the function? It is a complex exponential function. E to the power j omega naught t. जे ओमेगा नॉट टी है तो ओमेगा नॉट के टर्म्स में है दैट इज डेफिनेटली इन टर्म्स ऑफ ओमेगा नॉट नाउ एज वी नो दैट हमारा डेल टी का फूरियर ट्रांसफॉर्म 1 होता है और हमारे पास अगर डेल टी माइनस टी नॉट होता है तो e टू द पावर माइनस जे ओमेगा टी नॉट होता है सिमिलरली इफ आई एम टेकिंग अगर हमारा ये फंक्शन है तो आई एम टेकिंग डेल ओमेगा माइनस ओमेगा नॉट I may get this as my function. Inverse Fourier transform of del omega minus omega naught. I may get this as my function. So that was the reason that we tried it in this one. Now that's a homework for you people that just try taking this as xt and try to obtain the Fourier transform. Whether you'll be getting the Fourier transform as this or not. 2 pi then omega minus omega naught आ रहा है कि नहीं आ रहा है that will be difficult for you just try it out at home and if you find any difficulty I'll get back to you ठीक है but because of that reason that we were not able to find it we have come in this way it doesn't mean कि हमारा Fourier transform नहीं निकलेगा definitely we'll have the Fourier transform of it but we have to come in this way ठीक है हमें उसको reverse process में inverse process में जाकर obtain करना पड़ेगा So we have got that Fourier transform of e to the power j omega naught t is 2 pi del omega minus omega naught. Now the another function is a fifth one is a constant amplitude 1. ठीक है? Now if I am taking a constant amplitude as 1, again in this case 1 xt is just 1 it's a constant value okay what it is saying xt is just 1 and if I try to find out x of omega of it it will be integration minus infinity to infinity xt is 1 to the power minus j omega t dt and that is not possible again if I go in this way but that doesn't mean कि इसका Fourier transform exist नहीं करता है ठीक है because this one is minus infinity to infinity 1 is integrable and it has the finite value it is integrable मतलब minus infinity to infinity mod of xt dt लेंगे तो it will be t will be have the finite value मतलब कुछ भी अगर हम value लेंगे it will have the value ठीक है so e to the power minus j omega t dt this one will not have the value minus infinity to infinity में इसको integrate करेंगे we may not get the proper answer ठीक है so in this case also xt is not absolutely integrable ये absolutely integrable नहीं है ठीक है cannot find the Fourier transform directly हम इसका direct Fourier transform नहीं निकाल सकते in that case we will take the obtain the inverse Fourier transform of del omega ठीक है inverse Fourier transform of del omega हमने inverse Fourier transform del omega का क्यों लिया है because यहाँ पर xt is 1 और 1 किसका Fourier transform है 1 किसका Fourier transform है just del t if I am taking del t as my function what is the Fourier transform it is just 1 so here it is asking कि अगर constant ही हमारा जो function ही हमारा constant है since this is not absolutely integrable ये absolutely integrable नहीं है we will not be able to obtain by this formula but it doesn't mean कि उसका Fourier transform exist नहीं करता है it exists I have already said कि the condition that are sufficient condition but they are not necessary condition ठीक है so we have said we have to go in the reverse process we'll obtain the inverse Fourier transform of del omega now inverse Fourier transform xt is 1 by 2 pi minus infinity to infinity del omega e to the power j omega t d omega. ठीक है? In that case, this becomes 1 by 2 pi. This becomes 1 by 2 pi because this value will be completely 1. ठीक है? Because this exists at only omega equals to 0. So e to the power j omega t will have the value at omega equals to 0. So the value is 1 by 2 pi. That means the inverse Fourier transform of del omega is 1 by 2 pi. That means this implies that the Fourier transform of 1 will be 2 pi del omega. Okay, here is 1. If I am taking 2 pi this side, the Fourier transform of a constant value 1 will be 2 pi del omega. Okay, that is how we can obtain the Fourier transform of a constant value 1. This is how, since I have taken the inverse Fourier transform of del omega, I have applied it in the formula 1 by 2 pi integration minus infinity to infinity del omega e to the power j omega t d omega. And this value is just 1 by 2 pi. And we have got that the inverse Fourier transform of del omega is 1 by 2 pi. Now from this we can write that this is our value 1, constant that we wanted. Okay? So the Fourier transform of 1 will be 2 pi, take on this side 2 pi del omega. Okay? So this part is clear. So that is how we can obtain the Fourier transform of any function. Now it is not absolutely integrable. In this case also, and it is same in the case of e to the power j omega not t also. It will not be an absolutely integrable function. Okay? So in that case, we can go in the another way around. That is, try to obtain the inverse Fourier transform of any function. That is del, maybe del omega or del omega minus omega not or any other function. So in that case, we can be able to obtain the Fourier transform of the desired function, whatever is our function. Now since here xt is just a constant value 1, in that case, we can have the Fourier transform of 1 as 2 pi del omega. Clear now? So that's all for today's class.